So in a previous video, we looked at these solid-state music prototyping cards, the IO2s, and talked a bit about potential projects for them. And one of the projects I mentioned was using 1702 EPROMs to come up with a card to basically represent the ROM in my Altair. And so I'm kind of moving forward on that project. I have a small number of 1702 EPROMs here. These just came fresh out of the UV oven that I've been looking at. I've got a single 1702-6, which is a 1.5 microsecond or 1500 nanosecond part, really slow. I've got an AMD part, don't know the specs. I've got 3-2s that are 650 nanosecond parts, so really slow. And then I've got a number of just straight 1702As here that are the 1000 nanosecond or 1 microsecond parts. I'm going to need 8 of these, I believe, to get the entire Altmon programmed up. I'll have 4 extras this way, so I think I'm really going to focus on using the 1000 nanosecond parts, and I think that'll require me to actually add wait states for ROM access to the system as well. So with that said, I've got a 1702 EPROM programmer here. I've had this for ages. It was an eBay find many years ago. I've programmed 1702s on it, but I don't honestly remember exactly how it's controlled. I think addresses are on the bottom and data's on the top. And I believe I have to actually manually toggle them. It's just been a long time. So let's put the device in, that's right, in read mode. Let's just take one of these erased ones and drop it in. And I believe, so they programmed all zeros, which would be what we're seeing here. Yeah, in read mode I can't set the switches. So let's reset. And for now I'm going to focus on using some of the other parts here in case I make a mistake. I believe to write, we put the switch to write. I want to program address 1 with the 1. And we do a load. If we go back now and do a read, it didn't seem to do anything. Reset. Oh, looks like data's down here. So looks like we did program a bit. So this must be the address up here. So that represents an address. Yeah, you just saw some. Yep. And this is one of the known issues with this is it's got a. I've had it apart. It's got a bad connection inside, and these LEDs don't always light up as well as they should. I'm confused that that appears to have a 1 at address 0. Reset. Well, output. Boy, I really don't remember. I know this was for programming for like an alarm system. I believe, hey, there's some instructions on the side. Perhaps I should read those. I forgot this was here. Oh, shouldn't have done that. First warning, do not remove part. Set read-write switch to desired position, press reset if not in home position. H is home. LED lights will indicate the PROM output. Push step button to commit to the next step. Repeat step 6 until complete PROM has been read. Set the desired output switches 1 to 16. The LEDs will display the switch settings. I remember this now. This was for an alarm system, and you programmed it in 16-bit values, and these switches were labeled like 1 to 16 or 1 to 15. And so there was no concept on this front panel of there being address and data. It took me a while to actually figure this out. The LEDs will display the switch settings. 1 equals on. Set the desired output switch as 1 to 16. The LEDs will display the switch settings. 1 equals on. Push the load button. Display will be blank until load cycle is complete. The display will return with next step. Repeats 5 and 6 until programming is complete. So we're going to have to play a bit here, I guess. We've already tried to throw some data into that device. It's powered up, so we're at the home positions, what the H represents. Drop in another device. And pin. It's been a long time. See, I figured this out before. I have successfully programmed ROMs on it. I just don't remember. See, 8 of the switches are data, and 8 of the switches are address. I'm going to go to the right position, and I'm just going to do a load, 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 load. I'm going to come back to the read position. I'm going to reset. So these appear to be the data switches down here. Reset. So these do appear to be the data switches down here. So it appears data is down here low. And it appears it's picking up the address from here and then auto-incrementing it. So let's prove that. Let's reset. And let's go to the upper bank. Reset. No, we're still seeing. Is there just no way to set the load address? Interesting. So home is address 0, 1, 2, 3, 4, 5, 6, 7. Address 8. And this must be displaying the next address here. So now I want to go up to there's 16, 32. That can't be the current address. Reset. We definitely wrote that bit pattern. Okay, address 15. So this is the address to be loaded, not the address that's read in this case. What? Oh, it's showing the switch state. I'm not actually writing. We're in write mode. And let's do these upper bits here. Load, 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 load. Back to read, reset. Press 1. Looks like it didn't write address 0. Reset. Let's see if we can write AA at the home address. And go back to read and reset. Okay. So H's address, 0 is the home address, and now as we step the addresses, we should see the 15-bit up counter here, and then the 15-bit up counter here. Next address to be programmed. So one of the things that confuses me is this is, of course, displaying in decimal. This is going to go up to 127, and then it rolls back over to the home address. It's 2048 bits divided by 8. Am I just remembering wrong here? 256 word by 8-bit. So it really should be 8 address lines. So there should be A76543 210 0 1 2 3 4 5 6 7. So there are 8 address bits, so it really is 256 addresses can be programmed. Is it safe to assume? Maybe I really do need to toggle in the addresses on the upper 8 switches. Reset. Okay, that looks like it did maybe set a 7. Load. Let's reset. Reset. Now. It's actually interesting that reset. What is it reading here? Oh, I finally remember. I finally remember how this works. Wow, it's been a long time. This is going to confuse the grundle out of you, but I can explain how it works. I have the lower set of 8 switches that run data 7 to data 0, and I have the upper set of 8 switches, and they run data 7 to data 0. And what you're doing is you're actually entering 16 bits of data here. So in reset here, this represents address 0, and this represents address 128 decimal. So what's happening here is the byte that's being programmed here, A7 equals a 0, and the upper switch is A7 equals a 1, as I recall. So you've actually got to put in the byte. So in this case, we'd put in the byte at address 00, and we'd put in the byte at address 80 up here, and it would program those 2 bytes. And then we'd put in the address at 01 and the address at 81, and we'd set switches and would program those 2 bytes. So let's go prove that. Now that I think about it, I do remember that's how this thing works. I'm not supposed to I'm supposed to unplug it. I want to toggle the parts back and forth. So let's do a reset. And what we're going to do here is we're going to write, I'm just going to shift the bits across. So this should write address 0, which is home, and address 80 hex. Gotta go to write mode. And it's been a long time since I've mucked with this. 2, 3. I need to do those and those. So none of the switches are address. So if we reset now, we should get the bit patterns walking across just as we see. And there's that flaky LED there. So this LED down here on the end, you'll see it might flash on. It did in this case. It's just, it's flaky. If you bump it around and play with it, sometimes it'll light up. It was electronically packed dense enough. I really didn't want to tear any further into it. But it is programming the bit. It's just that the sense amp or whatever, there's something electrically wrong with that LED driver. So that's how it works. I remember this being a major pain in the ass now, because I had to go in and take the hex file I wanted and break it up into 2 chunks. So I would have the upper byte and the lower byte, I'll call them that, ready to go, and just a lot of switch flipping. So looks like it works, which is exciting. I can go ahead and erase these guys down here now. And I guess I need to go prep the data files for this, because it's going to be quite interesting to toggle in 2048 bytes of data here manually and get it right. So I'll wrap this little video up here, and we'll talk soon.